This is question 4 from paper 1 of the AS 2017 biology paper. And we start with a different format of graph that we haven't seen before from AQA. Just take a minute to rationalise what we're looking at there. We've got the volume of the ventricle on the side and we've got time over the x-axis on the base of the graph. We've got 4 things happening labelled 1, 2, 3 and 4. So to get my head around this graph, what I'm going to do is I'm going to start off at number 2. Because at number 2, it's a really obvious place. The blood in the ventricle empties because the volume decreases. For that to happen, the semilunar valve that opens into the aorta must be open. And if the pressure is high enough in the ventricle for that to open, then we know that the atrioventricular valve will also have just been snapped shut by the increase in pressure. So therefore, number 1 represents the atrioventricular valve closing, and number 2 represents the semilunar valve opening. Likewise, when I look at number 3 and 4, I can recognise that 4, the volume of the ventricle begins to increase. In other words, blood starts to enter. So 4 must represent the atrioventricular valve opening. And the atrioventricular valve actually opens because the pressure in the atria exceeds that of the ventricle. So that must mean that the semilunar valve is closing. So number 3 would be the semilunar valve closing. So my tip for that question would be to not necessarily use the order of the numbers that they've given you to work it out, but to look at the really obvious places where are an obvious starting point and then work backwards. The next part of the question asks us to use figure 3 to calculate the volume of blood pumped per minute by the left ventricle. So we're going to go to the graph. We're going to find out what was the top volume and what was the bottom volume to work out the volume of blood that leaves the ventricle each time. And we can see from the graph that 120 minus 40 is 80 cubic centimetres. We then need to find out how many cardiac cycles are in 1 minute. So to do that, we need to find out how long a cardiac cycle is. Now we can take any part of the graph that doesn't repeat itself. So choose a part of the cardiac cycle that is easy to read off the graph. So I've chosen 0.48 there, where it's at the base, where it's at number 4. And that starts to repeat itself again further down at 1.24. They're nice, easy numbers to work with and really easily identifiable on the graph. So if I take 1.24 and minus 0.48, I find I get 0.76 seconds. That's how long one cardiac cycle takes. So how many of those will fit into 60 seconds, which is 1 minute? What I need to do is take 60 and divide it by 0.76. And then the answer that gives me, I'm going to times it by 80, because each one of those pumps 80 cubic centimetres of blood around the body. So the answer that it comes out is 6,315.79. And they accept a range there from that number all the way up to 6,400 or 6,400. Okay, the next part asks us to explain the role of the heart in the formation of tissue fluid. To answer this question, all we need to say is that it's the contraction of the ventricles that produces high blood pressure. For the second mark, we just need to say that this forces water out of the capillaries into the surrounding tissues. So what was it about this question that made 74% of students score 0? Well, we need to be specific. We need to talk about it's the contraction of the ventricle and not the contraction of the heart. This is because it's actually the contraction of the left ventricle that produces the high blood pressure. It's not the contraction of the atria or the right ventricle. The other mistake that students made was that they weren't specific when they talked about the water. They talked about tissue fluid. The high blood pressure forces water out of the blood vessels. It doesn't force plasma, it doesn't force tissue fluid. Now, the water may contain some dissolved substances in there, such as glucose or oxygen, but we certainly couldn't call it plasma, because plasma is a thicker solution and it contains plasma proteins as well as many other substances. Moving on to the next part of the question, lymphedema is a swelling in the legs, which may be caused by a blockage in the lymphatic system. Suggest how a blockage in the lymphatic system could cause lymphedema. So when you get the command word suggest, we're asked to work it out. We're asked to use our knowledge to bring together an explanation. So 73% of students scored 0 on this, so it was answered equally poorly. To answer it, we needed to talk about excess tissue fluid building up and not being reabsorbed into the blood. This, of course, causes a swelling. And it's the idea of the excess tissue fluid that is draining away. Remember that the cells around that capillary bed will remain bathed with tissue fluid, but the extra stuff that's being forced out of the capillary blood vessels needs to be returned to the blood. So it's the excess tissue fluid. Now, I know how 27% of students will have managed to score 0 marks on that because they will have talked about normally. Normally what happens is blah, blah, blah. It's not asking you about normally, it's asking you about what will happen if there's a blockage. If you talk about what happens normally, you're asking the examiner to do the work. You're asking the examiner to work out what would happen otherwise. So you really need to focus on what the question is asking. So the key to this, once again, is about being specific in your wording, specific in your terminology. I hope the video has been of use. Don't forget to leave me a comment.